Hi, today I am going to talk on Mars planet. Can we make Mars planet habitable? Before I turn to the topic of this tutorial, if you are a new listener, subscribe to our channel, TP Info, and like our video if you find this video interesting. Now, I want to talk on the basic facts of the Mars planet. Mars is the fourth planet from the Sun in our solar system. It's named after the Roman god of war. Mars is also known as the red planet due to its reddish appearance. Physical characteristics of Mars: diameter, approximately 4,220 miles 6,800 kilometers. Mass, about 1/10 the mass of Earth. Surface gravity, about 38% of Earth's gravity. Atmosphere, thin, mostly carbon dioxide. Temperature, average -67 degrees Celsius -89 degrees Fahrenheit, ranging from -125 degrees Celsius -193 degrees Fahrenheit to 20 degrees Celsius 68 degrees Fahrenheit. Geography of Mars planet. Mars has the largest volcano in our solar system, Olympus Mons, which stands at 27 kilometers high and has a base over 600 kilometers wide. The planet has the longest valley in our solar system, Valles Marineris, which stretches over 4,000 kilometers. Mars has polar ice caps, which are made up of water ice and dry ice frozen CO2. Mars planet. Can we make Mars planet habitable? Bringing life to Mars is a fascinating concept that has garnered significant interest and research in recent years. Here are some steps that scientists and space agencies propose to make Mars habitable. 1. Warming the planet. Mars is extremely cold, with average temperatures ranging from -125 degrees Celsius to 20 degrees Celsius -200 degrees Fahrenheit to 70 degrees Fahrenheit. Releasing greenhouse gases like carbon dioxide could trap heat and warm the planet. Use mirrors or other methods to focus sunlight and warm the surface. 2. Creating an atmosphere. Mars' atmosphere is thin and lacks oxygen. Releasing gases like nitrogen and oxygen could create a breathable atmosphere. Use comets or asteroids to import gases. 3. Establishing a magnetosphere. Mars no longer has a protected magnetic field, which is essential for shielding the planet from harmful radiation. Deploying an artificial magnetic field or magnetic shields could protect the planet. Use powerful magnetic fields to deflect harmful radiation. 4. Melting ice caps. Mars has ice caps at both poles. Melting them could provide water sources and create a stable water cycle. Use mirrors or lenses to focus sunlight and melt ice. Drill into ice caps to release water. 5. Terraforming. This involves making significant changes to the planet's surface, like creating oceans, lakes, and rivers to support life. Alter the planet's surface to create habitats for life. 6. In situ resource utilization. Using Martian resources, like water and regolith Martian soil, to support life and propulsion systems. Extract resources, like minerals and metals. 7. Robotic and human exploration. Sending robots and humans to Mars to prepare the planet for human arrival and establish a sustainable human presence on Mars. 8. Biodome construction. Building enclosed environments that can support life, like biodomes or greenhouses, to cultivate plants and to keep animals over there. Create habitats for plants and animals. 9. Genetic engineering. Modifying organisms to thrive in Martian conditions, like low pressure and radiation. Create new species adapted to Mars. 10. Ethical considerations. Addressing the ethical implications of introducing life to another planet, like potential contamination and the responsibility to preserve Martian life, if it exists. Please note that these steps are still purely theoretical and require significant technological advancements, infrastructure development, and scientific breakthroughs before they can be implemented. Using nanotechnology to alter the planet's surface. Creating a Martian ark to preserve Earth's biodiversity. Establishing a lunar gateway to support Mars exploration. Using Mars moons, Phobos and Deimos, as resources or habitats. Again, keep in mind that these ideas are still purely theoretical and require significant scientific advancements and technological developments before they can be implemented. Is it possible to use robots to make a habitable environment on Mars? Robots can significantly contribute to making Mars more habitable for future human exploration and potential settlement. Here are some ways robots can help. 1. Preparation of landing sites. Robots can clear landing sites of debris, rocks, and other obstacles to make the ground level and create a stable surface on Mars planet, ensuring safer landing conditions for future missions. 2. Construction and assembly. Robots can build infrastructure, such as habitats, life support systems, and place solar panels, using local materials like Martian regolith. 3. Life support systems. Robots can establish and maintain life support systems, including air, water, and food production, recycling, and waste management. 4. Radiation shielding or protection. Robots can construct shielding to protect against harmful radiation from the sun and deep space, creating a safer environment for humans. 5. Atmosphere alteration. Robots can release greenhouse gases to warm the planet and create a breathable atmosphere. 6. Resource extraction. Robots can extract water, minerals, and metals from Martian resources, supporting human life and propulsion systems. 7. Scientific research. Robots can conduct experiments, gather data, and provide insights into Martian geology, climate, and potential biosignatures. 8. Maintenance and repair. Robots can perform routine maintenance, repairs, and upgrades to infrastructure and equipment, reducing the need for human intervention. 9. Transportation and logistics. Robots can transport materials, supplies, and even humans across the Martian surface. 10. Precursor missions. Robots can pave the way for human missions by establishing a reliable presence on Mars, testing technologies, and demonstrating feasibility. Robots can perform these tasks using various technologies, such as autonomy and artificial intelligence, manipulation arms and greepers, mobility systems, wheels, legs, or aerial, sensors and cameras, drilling, excavation tools, and 3D printing and additive manufacturing. By leveraging robots' capabilities, we can overcome some of the significant challenges associated with making Mars habitable and prepare the planet for future human exploration and settlement. Some specific robot designs and technologies that could support Mars planet habitability include: 1. Robotic arms and greepers for construction, maintenance, and resource extraction tasks. 2. Mobile robots for transportation, reconnaissance, and surveillance tasks. 3. Aerial robots for reconnaissance, mapping, and communication tasks. 4. Subsurface robots for resource extraction, tunneling, and habitat construction tasks. 5. Swarm robots for tasks that require multiple robots working together, like construction and resource extraction. 6. Autonomous systems for tasks that require minimal human intervention, like life support systems and radiation shielding. These robots could be designed to operate in Martian environments with features like radiation resistance, to withstand harmful radiation, low pressure tolerance, to operate in Martian atmospheric pressure, low temperature tolerance, to operate in Martian temperatures, dust resistance, to withstand Martian dust storms, autonomy, to operate independently for extended periods. By leveraging these robot designs and technologies, we can overcome some of the significant challenges associated with making Mars habitable and prepare the planet for future human exploration and settlement. For more informative videos, like and subscribe to our channel.